Hi guys, and welcome back to the ACE Academy. In this video, we'll be looking at quantization of charge. The first hint at what we're going to be working with in this section comes from the name of the section itself. Quantization of charge. Quantization comes from the word quantity, so we are going to be working with the quantity of charge, quantity of electrons. Let's be logical for a second. In the introductory video for this section, we learned that electrons are the only subatomic particle that we work with that is able to move or travel between particles, atoms, and matter in general, right? That means that electrons are responsible for the charge on an object. So if electrons are responsible for the charge of an object, that means that the net charge on an object should be divisible by the charge on the electron, because the charge on the object is just a multiple of the charge on the electrons. Right? We know that the charge of an electron is actually negative 1.6 times 10 to the minus 19 coulombs. Simply, the law of quantization of charge states that every charge in the universe is an integer multiple of the charge of an electron. When I talk about integer multiple, I am referring to whole numbers. That means that we will not get a decimal for the number of electrons, because electrons are to be treated as a whole. This is best understood by a silly analogy. Let's say I had 3 people and I wanted to divide these 3 people into 2 equal groups. I cannot put 1.5 people in each group because a person needs to be treated as a whole. In a similar manner, we do not divide electrons, we treat them as whole entities. Now, why is this law useful? This is simply because if we know that every single charge in the universe is an integer multiple of the charge of an electron, we are able to calculate the number of electrons on an object. Another useful part about this law is if we know the number of electrons in an object, we are able to calculate the charge of the object itself. Let's create a simple word equation for us to understand how to work with this bit of information. The net charge of an object is equal to the number of electrons multiplied by the charge on an electron. If I put symbols to that, I will get Q net is equal to N times QE, where Q net is charge of an object, N is number of electrons, and QE is the charge on an electron. I can algebraically manipulate this by changing the subject of the formula to the number of electrons, and I would be able to calculate the number of electrons on an object by using its net charge divided by the charge on an electron. Let's go ahead and do some examples on these 2 different scenarios in order to reinforce the theory that we've just covered. Looking at the first section, the question asks us to calculate the charge of an object with the following number of electrons. So simply, we have been given the number of electrons that an object possesses, and they are asking us to calculate the net charge of this object. Now, a lot of you might find that due to the fact that I have a decimal, it contradicts what I've said earlier in this video, that every charge in the universe is going to be an integer multiple of the charge of an electron. And here I got 3.125. But in fact, let's take a closer look. I don't just have 3.125. I have 3.125 times 10 to the power 21. That times 10 to the power 21 increases the number from a decimal. This is just scientific notation. So in fact, this is a really large number, right? Let's use the formula to calculate the charge on this object. The net charge on an object is equal to the number of electrons times the charge on an electron, substituting the number of electrons as 3.125 times 10 to the power 21, and substituting in the charge of an electron, which is negative 1.6 times 10 to the negative 19, I would obtain negative 500 coulombs of charge. So the charge of an object possessing 3.125 times 10 to the power 21 electrons is negative 500 coulombs. In the second scenario, for this question, we have 6.25 times 10 to the power 19 electrons. Let's calculate the net charge on this object. Q net is equal to 6.25 times 10 to the power 19 multiplied by negative 1.6 times 10 to the negative 19, and I would obtain negative 10 coulombs of charge. This means that if an object possesses 6.25 times 10 to the power 19 electrons, the object's net charge will be negative 10 coulombs. Let's look at the second scenario for this law. In this scenario, we are going to calculate the number of electrons that an object possesses when we are given the net charge of the object. In the first part of this question, we have been given a net charge of -8 coulombs. Let's go ahead and use the formula to calculate the number of electrons. We know the number of electrons is equal to the net charge divided by the charge on an electron. Therefore, the number of electrons is equal to -8 divided by -1.6 times 10 to the -19. And that would simply give us an answer of 5 times 10 to the power 19 electrons. So if I have a net charge of -8 coulombs, I would have to have 5 times 10 to the power 19 electrons in that object. Let's go ahead and work with question 2. If an object has a net charge of -11 coulombs, and I wanted to calculate the number of electrons that object possesses, I can simply substitute in my values, where the net charge on the object is -11, and the charge of the electron is -1.6 times 10 to the -19, and I would obtain an answer of 6.875 times 10 to the power 19 electrons. Keep in mind that this is an extremely large number, and that is the amount of electrons that an object will have to possess in order to have the charge of -11 coulombs. That's it for me, guys. All the best, and I will see you in the next one.